will be performing this webinar on the VMS-333. This is a 30-minute long webinar. We will start with an introduction to the VMS and a brief history. Go ahead. So today in this webinar, we will be overviewing Red Hen Systems' history of the VMS-333, an introduction, features, setup, output, and features of the VMS-333 or future VMS-333. And then we will be taking your questions, which you can type in the little question box there, and we will do our best to answer them within the time frame. If you have any other further questions, our contact information is at the end of the presentation, and you can contact Chris or myself in later time. Go ahead and do the next roll. Here what you're seeing is the previous VMS models. Our first model there was the SDVR. It was more of a computer. It had its internal recorder there. It had a hard drive. It also took multiple cameras. And I don't know, Chris, do you have any other inputs that kind of made that one what it was?
I never worked with it myself, but from what I remember in support, people do like that, the SDVR. Now, we still do repairs for them, but we don't make any more, mainly because it's a little difficult to put together and maintain, and some of the components are a bit outdated. So we've moved to a more modular approach.
Mm-hmm. And then, as you see below, the VMS 200 and 300 are very similar designs. They have that battery pack on the top there, and they actually only outfit one camera. And has a coaxial or an auxiliary GPS attachment there. Chris, do you have any other information that you would like to provide about the 200 and 300?
Oh, for those models, they were, like you said, used for one particular camera. They were also able to decode audio at the same time, and I believe they were also used for camera recorders that use digital tape. As for the form factor, it's not quite convenient and takes a little time to get used to, but once you do, it's pretty easy.
And just to note that these models have been discontinued for the newest version of the video mapping system, which is the VMS-333, which is what we're going to be talking about today. Next slide. So our introduction to the VMS-333 and why you might want to be using the VMS-333 in your surveying is because it enables metadata streams through the audio to record up to 4 cameras, and things that you might want to put in that metadata is obviously your GPS. That's why you're using the VMS. Environmental information if you're putting in weather data, commentary, and features of interest. We also work with multiple other sensors. If you have a special case, please contact us and we'll find out if we can make that happen. Chris, are there any other reasons why you might want to use the VMS-333?
Well, if you have a particular sensor that you want to geotag data with, the VMS-333 is quite capable. We even have a multiplexer that we've been working on to allow for different sensor data, or multiple sensor data that you may want to integrate in that as well. The BOREAL gas finder is one of those offshoot sensors that we've been working with quite extensively. Even a laser rangefinder, if it's outputting the MIA, can be integrated with the VMS-333.
And is all data that can be put into the VMS in the MIA?
Yes, but if your sensor outputs something that's non-NMEA, we can still build something that would make it compliant.
Okay. So here are some of the combinations that you might be interested in attaching. Obviously, we had talked about the 4 cameras that can be attached to the VMS. The 4 cameras are attached to the VMS using a 3.5 millimeter audio jack. We also have a Bluetooth module inside the VMS, which allows the GPS, if you have a non-hardlined GPS puck, or a GPS fob, if you will, to be attached to the VMS-333. Also, it allows our VMS to be connected to a tablet, an Android-based tablet or cell phone, enabled with VMS Mobile. And what VMS Mobile allows you to do is create custom feature triggers. And Chris, do you have more elaborate or any information that you would like to add about VMS Mobile and how it can integrate with VMS-333?
Yeah. Now, VMS Mobile can place custom name feature triggers. So if you are looking for a particular landmark, or if you see something that isn't easily referenceable, you can still change it on the fly. So if you see a downed power line, or if a tree is over a road, or whatever, you can actually enter in that custom name and use that feature trigger during your patrol. And whenever you're reviewing your data, as soon as you import your video and it performs a decode, it'll actually show a label on your map of that particular item of interest. Now, it's also useful for intervalometry. If you have a Nikon with a 10-pin, you can have it automatically perform sequence capturing. And VMS Mobile also has a live map that allows you to see where you are on relative to your patrol. And any previously made feature trigger events, it'll display those as well. You can pre-cache map tiles, so you don't have to always have access to the internet. You can also save data as a KML. VMS Mobile does act as a backup for your track and sensor data.
Well, and that enables VMS Mobile as a very powerful tool that does not come standard in the VMS Mobile package. If that is something that you are interested in, please give us a shout, and we can figure out how to get you VMS Mobile. Going on, we pretty extensively covered the feature triggers. One does come with your VMS Mobile basic kit that allows you to designate a point at which you have interest in and would further like to go into it. For the LRS, so laser range finders, we work with 2 models. Particularly, we work with LTIs, and it's the 360R and 360B, or the Tru-Pulse, are the 2 common models that we work with. We also work with that Vectronix there, which is what you see on the screen in the center. That's a very powerful laser that we use in our military applications. Something of interest would probably be that we work with the Tremble GPS, which can increase your accuracy depending on what, how accurate you want, sub-meter or sub-centimeter, or, centimeter accuracy. That can change accurate you get. So we do work with that. Communications, we do offer a connection for headsets as well as a little fob that you use and will inlay into the right side of the audio stream to be matched up with the video for dissemination in ISWare or ArcMap later on. And as Chris had spoke about, the Nikon intervalometer, which allows you to take sequence pictures every second, if you will, or every half second, and then those can later be stitched together and create maps. Chris, is there more that you'd like to expand on the NMEA side of VMS that we didn't touch on?
Yeah, so if you're using a laser rangefinder, and as long as it outputs NMEA, we can actually work with that. And if it doesn't, then we just need to do a little bit of development to account for that particular laser. In fact, a number of years ago, we had to account for, I believe it's a Atlanta type laser, and that did output different NMEA string than the Tru-Pulse or the Vectronix. In fact, the Vectronix doesn't output NMEA per se. It's actually a hexadecimal type format. Now, for GPS, if you're using a receiver that actually outputs that via Bluetooth, the VMS can pick that up. We've had a number of clients ask about this, and it does work. The only things to consider are if you have too many Bluetooth GPS or Bluetooth devices in the area, it might cause a little bit of interference. And like with all Bluetooth, you may just need to wait a little while for it to actually get an acquisition, but it does work. I should probably elaborate further on the technique that the VMS is using. Now, in a video, digital video, the data that we're integrating into that file is in it has an audio tone, and the recorder is expected to record in stereo and have a microphone input. And we embed that data in the left audio channel, and if there's any commentary or dialogue during a patrol, that would be recorded in the right audio channel. And whenever you come back to your headquarters to review the data, that left channel will be decoded with our software, and it'll pull out the NMEA data that was inserted in there during the patrol, and it'll insert time codes, video time codes for each line. And whenever you play back the video, that left audio channel will be muted, and the right channel will be all you hear. So you just hear commentary and dialogue as you play the video.
And what about the RS-232 input data?
Now, that's the primary signal format that we'll take. I believe if you have a device that's outputting TTL, we can convert that as well. But primarily, it's RS-232 compatible.
Okay. And I see that we're getting some questions now. We will answer those at the end of the little webinar here. So please stay on. We will get to them. And the more questions, the better. So keep them coming. Chris, next slide, I think. And I think we're about at our setup here for the VMS. So we will show you real quick how you get this set up. But first, in the VMS-333 basic kit, you'll be getting a battery a GPS receiver puck, a future trigger. Does not come with the camera, just want to state that, but you certainly get a 3.5 millimeter jack to hook up your camera. The comms and the power supply that allows you to connect to the wall. Is where is covered but is not covered in this webinar. That is at a later date. Please join us on April 12th, 2016. I think that's at 11 o'clock as well, for a demonstration of ISWare and all its fantastic features for getting and using this information that you just collected with your VMS-333. So we're going to go to live feed here, and we're going to kind of show you the setup here, and me and Chris will show you how to put your VMS-333 together. Let's make sure that that's somewhat clear. Well, hopefully that will focus here. Real quick, I'm Ian, that's Chris right there. This is the SDVR. Obviously, you can see that it's fairly large. I don't have, banana hands here, but it is a fairly large device. As you can see right here, this is the VMS-333. For those who do not have one, it is not even a comparison at where you can, put this thing in a helicopter. Doesn't weigh anything. Not that that weighs a whole lot either. Over here we have some comm set, and as well, here is the VMS-200. We are currently working on trying to get this focused. We'll do our best. As well as right here, we can see the DMRT kit. There we go. Got it focused. This is a VMS that's kind of been integrated with internal battery system and is set up just to work with the DLSR here, this Nikon that has this 10 pin on the other side and this Vectronix laser. You can see that the setup here is, wired. Oops, there we go. And what you would use this for, this is just kind of a different variation, if you will, of a VMS, but a VMS nonetheless, is to take pictures, acquire standoff distance, and then later disseminate that information over ISWare or over ArcMap using Jim to MISB. So what we're going to do here is set up our VMS and power cable here, and you're going to use these little, what are these, 10 pins cables, these high rows.
Yeah, they're 6 pin.
6 pin rows, sorry. And you just connect it, and this one's going right in the comms. You'll feel a click. It should be fairly secure when it connects. In your kit, you're going to get this battery here. It's a 12 volt or 9 volt battery.
It's adjustable.
Adjustable. There you go. And you can power that guy up. You'll see these little lights go. This guy's fully charged, thankfully. And then what we're going to do is we have our GPS puck here. That's going to be attached. And we're going to attach that guy right there. And then, this is kind of this simple setup. We're just showing you how to hook up the camera, acquire GPS. Now, this camera you might see, it's been modified a little bit. This is a Sony V1000X or X1000V?
X1000V.
X1000V. And this is a 4K camera that we've modified with a C mount and a CS mount, or is it C+? The C mount and CS mount. We have 2 little adapters there, so it's got this adjustable variable lens here. It's not automatic, but it is a really, really great camera to use to do collects. It's nice and light. It actually does have a GPS inside it. It's not the most accurate in the world, but that's why we're pairing with VMS here. to increase that accuracy. But it's got an audio port. So keep it in frame. It's actually underneath this little puck here. If I can get this guy open, which has been cranked down pretty good. There we go. So there's a little audio port that's covered by a flap there. This is an action camera, so it's got a whole bunch of holders out there that you can mount and that kind of stuff. But just plug in the audio port right there. Now it's hooked up to the VMS-333, and we're just waiting for the VMS-333 to acquire a GPS signal, which won't take too long because we're in civilization here, or at least we like to think so here in Fort Collins. And Chris, are there any features that they should know or be aware of on the VMS? Obviously, we have a little blinking light there. I'm sure you guys can kind of see, and we have this glowing light for the power. That's the power button right there, and then the audio wheel. Chris, would you like to talk about any of the other features there?
Yeah, no, this red button here is the feature trigger button. We do have an extension cable, so if you're not near the VMS unit to trigger the feature trigger, we have a cable that would plug into this far left port. And basically, it's a generic feature of interest. So whenever you come back to review your data, you'll just see a little icon on the map indicating that the feature trigger was pressed. And every time it's pressed, I don't know if you can hear that, there will be an audible beep. And if you're wearing a communications headset, you'll also hear that as well. This volume dial is for, we just got GPS, is for adjusting that audio tone for the feature trigger. This USB port is not used for any other purpose besides firmware adjustments on our end. You don't need to do anything with that. On this side, there are 4 3.5 millimeter audio jacks. You can connect up to 4 different cameras,
which we will connect our camera right now. We're just going to put that in one there. So now we're connected. And
this far left port is used for the extension for the feature trigger, or connecting a laser rangefinder, or whatever sensor you may need to associate with your GPS data. Second from the left is for the GPS receiver, although if you have a Trimble that's outputting GPS via Bluetooth, you won't need to connect anything to this port at all. The VMS will pick it up automatically. This next port is for power. Doesn't have to be used. The last port can also be used for powering. And for intervalometry, the second from the right is also the power port, would connect to a Nikon. And your communications would be plugged into the far right. I'm just going to do that real quick.
So we're just going to connect the comms here, this headset. Here you go, Chris. And here's your comm set that you'd potentially be using in your helicopter, unless you want some serious overkill for driving down the road, doing a road survey. And one thing that, while Chris is doing this, and you can watch him do this, is I'll plug our little Bluetooth can. It doesn't quite deserve a full webinar or explanation, but it is a Bluetooth-enabled little keyed fob for the Nikon, and you could connect that to the VMS-333 and then input that data into your Nikon. And for the Nikons, we work primarily with the 800, the 810, and I think the 750 and 300 are the DSLRs that have the 10-pin input into the Nikon. And that just allows you to store that information into the camera frame. I believe Chris has got that all set up. He's got this camera going. If we turn on the camera, we will be recording. Let's see, I believe that's going now. Yeah, we're recording GPS information. It's being inlaid into the video stream there. Actually, well, the left audio channel, as Chris had stated, that can later be decoded by our software. The benefit of doing it this way is that when you go to chop up the video or segment it or whatever you're going to do with this, is that it doesn't destroy the GPS data or inlaid metadata in the frame that would be potentially done on other methods of storing GIS information in a video stream. And Chris, do you have any other stuff that you were going to add?
Well, that's basically the setup for the VMS for the most part.
Right. And this is a fairly basic setup, you guys. We have more complex setups using the BOREAL and atmosphere information being plugged in. Again, we do have the multiplexer, which adds additional ports to the VMS-333. It just takes a quick little modification there. But I think we're going to speed it up here because we're kind of running short on time. And we'll just go to the next slide here and we'll end this visual demonstration. And again, if you guys have any other questions we don't get to, please send us an email or give us a call. We're more than happy to answer them. The future of the VMS is the VMS, what we've deemed as the 9DF, the 9 degrees of freedom. What this has is an internal IMU, so it has directional information in it. It will connect to more sensors. It will be easier to use and compatible with more things out there. And Chris, did you have anything you wanted to add to the future of the VMS?
Well, basically more sensors. We're going to make it easier to use. Compatibility with more cameras and recorders. And also more support in terms of training, video tutorials, lots of documentation.
And I think our next is to answer your questions that we've been getting throughout the webinar here. It looks like the first question, do you want to go to the next slide? There's our information there. Ian, Senior Account Manager, shoot me any emails if you have questions in the future if you think of them after this webinar. First question is, any recommendations for digital recording hardware or the format optimizing the VMS-333? Chris, do you have any recommendations?
Well, we've worked with a number of different recorders. There's the Vitex series. We've worked with Go Pros. We've worked with Sony cameras. We've worked with Panasonics. Recently, we've been working with the Atomos Ninja 2s. Usually call them Atomos, but and
Tomato, tomato.
Also the Convergent Odyssey as well.
Those are really great devices, not to jump in on you. The benefit of running with the Convergent, especially the Q7 Plus, is that it takes up to 4 video channels in one recorder. So obviously it pairs very nicely with the VMS because of those 4 video channels. I think I see a question there. Only 2 rangefinders, 2 rangefinder models. Only 2 rangefinder models with the Tru-Pulse lasers. The Vectronix, I think we've only tried to work with that one. It's the PLRF 25C if I'm not mistaken. That's the only one that we've worked with from Vectronix. If you have a particular model that you're interested in, please let us know. We'd like to add it to our inventory of devices we can operate with. What's that third question there? Assume that you need a 333 to decode video audio track information after collects. Code. Okay, so to best answer that question, I assume that you need a 333 to decode the video audio track information after collection. Is there a
short answer is no. Our software can decode it, which will be covered in another webinar session. But the software just needs the video that's been recorded. You don't need any hardware to decode that. Before, in the past, you would have to have the hardware in order to decode it, but not anymore.
Okay. In your demo recorder in the camera, how is it connected to the camera? So the camera is receiving the audio stream that is being inlaid with the GPS information. And I know we're just a little bit over our time right now. We'll try and answer all your questions. Hopefully you guys can stay. If not, we understand. Please shoot us an email and we'll answer your questions later. But to answer the question, the GPS signal is being put into the audio stream of the video camera. If you're only using a camera head that has no audio recorder function to it, that's where you would go to one of these Atomos or Odyssey or Vitech recorders that can receive an audio stream, and then that information would be together. The other question, what are the power requirements if the external power is used, voltage, current? That's a question for you. I think it's, what, 7.5 volts?
It has a pretty wide range of acceptable inputs. I think, yeah, 7 volts to, I think about 28 volts will work. There are safety measures built in, so you can't destroy the unit if you accidentally plug in the power cable to one of the other ports, even though they're the same Haro type connector. You won't break it that way. Yeah, I mean, it has regulators in it as well, so you don't really have to worry about that so much.
And does that answer Nick's second question there? Is there a ground lug on the VMS-333?
If you're referring to audio ground loops, we can include a ground loop filter sometimes to help prevent any extra noise getting in. Now, the VMS audio tone is somewhat similar in sounding to maybe a fax machine, but that is how we are representing GPS data and whatever data is being embedded as well. Mm-hmm. And we have software that can decode that and turn it back to something more meaningful, mm-hmm. and put everything on a map and represent it properly.
Can I connect a GPS unit, i.e. a Garmin, to the VMS-333 via USB or RS-232? How do you decode the VMS data, and what formats of the video are you supporting? MPEG, or what about HD? I'll let Chris answer this one. He'll probably be more articulate than I am about it. Take it away.
So going backwards, we do work with HD. We even work with 4K video. As for the formats, we've worked with MP4s, MOVs, MPEGs, MTSs, MT2Ss. Our decoder primarily uses a direct show to decode, and we are working on one that utilizes Media Foundation, which is what Microsoft is moving towards. Now, decoding the VMS data, those are the tools that we primarily use to do it. Now, it should be a RS-232 input for the GPS. If not that, then if you have something outputting via Bluetooth, that'll work as well, just fine. But if you have something that has a USB output, we could probably make something to convert it for you. That's pretty easy to do.
And yes, we can connect a GPS, a Garmin. Does it work with the USB or the RS-232?
Preferably RS-232.
Okay. And then we'll take this one last question, and then we're going to have to sign off. But please join us for the ISWare webinar. Again, that's April 12th. And I believe 11 o'clock you should all probably receive an email about it. But is VMS-333 created automatically unusable or usable files for the FMV and ArcMap? To answer that, no, it creates a gem file, which is our proprietary style file, and then you would use another software called Gem2MISB to create a KLV file, which is readable in ArcMap. Is there any other, did I miss anything in there?
More details will be probably discussed in the webinar for Gem2MISB regarding that.
Right. Okay. Again, everybody, thank you so much for joining us here at Red Hen's webinar for VMS-333. We hope to see you again. Have a great day. Thank you.